from over the last, 15 years that I'm now here. And I really learned a lot from how this university is being run and a lot of the details. So Ahmet actually got his bachelor's from Middle East Technical University in Ankara in '78, then got a master's from Bogazici, and got his PhD in 1984 from Rensselaer, all actually in chemical engineering. And then he became first a visiting assistant professor here, and then an assistant professor in 1986. That was when it was the Department of Chemical Engineering, which became Chemical Engineering and Material Science, and again Chemical Engineering by now. Ahmet got tenured in 1990 and full professor in 1996. He was vice chair from 2008 to 2011, and then chair from 2011 to 2014. And he was promoted to above scale distinguished professor in 2017, so at the beginning of this academic year, which is the reason for this milestone lecture. Ahmet actually won a few awards. He was a Tariq Sommer Awarded lecturer from MITU in 2005. He was guest professor at Beijing University of Chemical Technology in China. He will actually go this fall on a very highly distinguished visiting professorship at TU Denmark, in just outside of Copenhagen. And he also, this year, became a fellow of AICHE. He has written a textbook together with Roman Yomi, which is an introduction to process control and actually being used by a number of universities. He's also on an industrial advisory board from one of the refineries in Turkey. And he actually has done unbelievable service on all levels of the university. If I would start talking about that, he would not get to his talk. So, Ahmet, please come and tell us what you have been doing in the last few decades.
Thank you very much. I don't know if my face is showing red, but yeah, thank you. This was slightly embarrassing. Thank you very much, Roland. Really appreciate it, and it is all mutual as well in terms of learning part of it. Thank you to you all for coming and allowing me to celebrate this, promotion with you. So today I'm going to talk about all this. So I was trying to think of a title, but I said, this is no title is going to be really fitting to this, so I just put everything in there. But I think I like the alternate title, so I think I'm going to focus more on the second part of it. But before I really start talking about all the stuff, I'm going to start with a acknowledgement. As you all know, the journey is all about the people with whom you share it, and I'm going to start with my family, with my wife, and my daughter, my son, and our newest addition, our daughter-in-law. And with their obviously support and inspiration, that's why I'm here. And of course, another group of people who I derive support and inspiration from is this bunch of people. Hard to see perhaps as Tanya walks by. She's right there. And of course, there's an asterisk here. And there's a reason for the asterisk, because this picture, of course, doesn't include quite a few people. And I have to start from Joe Smith, Steve Whittaker, Dick Bell, Alan Jackman, Brian Higgins, Peter Struve, Dewey Ryu, who are not shown here, as well as our material science colleagues with whom we shared a department for about 20 years. As well as many staff, going back to Ann Jones, Tracy Lade, Archie Johnson, Elisha Bartolomucci, Jeff DeRopp, Chris Durr, and many others, as well as the current staff that who are, of course, here as well. I really appreciate it. Such a, 3 decades of work is not possible if you don't have good students, and I was blessed to have a bunch of them. There's the master's and PhD students whose work you're going to be seeing in the next several slides, and I'm going to talk in more detail later. I also had I was lucky to have a bunch of visiting students, and they were really terrific, and they allowed me to do a lot of good work. And and they are also went on to do very good things themselves, along with some few visiting undergrad students who turned to be very, very nice as well. And I haven't included our own undergrads with whom I, of course, worked quite a few times, and their names wouldn't even fit one of these slides. Among the collaborators, and when I say collaborators, people that I work with, wrote proposals with, wrote papers with, there are quite a few, as you can tell from this sort of slide. And I really appreciate it, the chance to be able to work with you, all of you. And as Roland was saying about learning from me, I learned a lot from each and every one of you. And you can see this is a pretty diverse group of faculty members, both in the department and also outside the department. External collaborators, I listed them here, some of them, just to make sure that I acknowledge them. I'm sure there are quite a few that I'm missing as well, and they cover all kinds of people from all parts of the world. And as I said, I was lucky to be able to work with all of them. So, what will I talk about during this seminar? First and foremost, I'm going to present, as I said in the beginning, a travel through time. And I'm going to include quite a few pictures. If you like old pictures, you're going to enjoy the seminar. And we were talking about this with Roland before the seminar. This is my first and last Milestone lecture. So indulge me, I hope, in going through some of these things. And actually, it was very nice for me because it gave me a very nice sort of travel down the memory lane. And so it was quite nice for me to be able to put this seminar together just because of that as well. So I'm going to go through some personal stories and landmarks. And of course, Roland mentioned a few already, so I gave some of the story away. But that's okay. And I'm going to focus a bit on the research side as well. I'm going to talk about, but I'm going to just summarize a few things and then just highlight, because there's so many kinds of things apparently we have done over the last 30-odd years, and it doesn't make sense to go into a whole lot of details. And then I'll finish by sort of focusing on what we're doing currently and what the plans are for the near future. So the story starts here. Eastern Mediterranean, the country of Turkey, and starts in 1956 in the city of Istanbul. My parents met in college, and when my dad graduated from medical school, they got married. A couple of years later, I was born. I was a pretty happy child. I don't remember a whole lot of those days, but all the stories that I heard, apparently I was a pretty happy child. And then because of my dad's work, our sort of journey took a bit of a circuitous route. So after he graduated, he went to Ankara for his residency. So obviously we went along with him. So after a few years there, during which time my brother was born, and then he was, after he finished his residency, he was assigned to a hospital in Sivas. But he didn't stay there too long. I think we only stayed there like a year and a half. I vaguely remember that place. And then we ended up in Uşak, which is essentially in the western part of Turkey, close to Izmir, over here. And but Uşak was kind of a interesting town, very rural. As you can see, there's an ox cart going down the main route here in the street. So I'm looking at the picture actually from our balcony, in the apartment's balcony. And so here, of course, in the summers, we went down to the coast, spent a good time there. Me and my brother, you can see in my dad's Chevy back there. So I went to school in Uşak, starting with the elementary school, during which I honed my acting skills. So this is our, I think this is second grade or third grade. And then I finished junior high here. This is the characters from my class. I'm right here. Our principal is back there. I mean, he looks pretty stern, but he was a very nice guy. And then, while I was in junior high, there was a weekend that was put together as a scout camp. Our PE teacher, who's here, so got together with this fellow, who's actually an American, who came, I'm guessing, as part of the Peace Corps at that time. And during that time, quite a few actually Peace Corps volunteers were coming to Uşak to give teach English and engage in, I guess, civic activities. So he was there, and so we spent learning about how to tie ropes and do scavenger hunting and all that stuff. That was kind of interesting. So along the talk, I don't know if you can sort of see some symmetries, some threads, some sort of foretelling of the future in some cases. Again, this is the first time I guess I met an American. So, and then I went to high school. So the high school was in Istanbul. This was a private school, a boarding school, called Robert College. At that time, it shared its campus with a university called Robert College, and the high school was called Robert Academy. So this was our actually dormitory. I stayed in these rooms up there during that time. In '71, the boys' school split from this campus and joined the girls' campus. So that's what we said. But guess what the girls said? No! But so it was a good, I mean, it was a bit of a hard transition, I think, for everyone. But at the end, it was quite nice. So this is from the years of the Robert Academy, posing at the top of Bosphorus with my friends. This is the picture of us, three of us, the three musketeers, as we called ourselves. This is Athos, Porthos, and myself, Aramis. And I continued my acting career in high school as well. So did some drama. And then we graduated, and by the time we graduated, we actually were quite well integrated. I mean, we made some great friends. And I don't know, Bruce is here, right? And catalysis people might recognize Ümit Özkan, Ohio State professor. So she went on to do some great things as well. So at that time, the decision was, okay, now we're graduating. Where do we go? There are two choices, really. Boğaziçi University or Middle East Technical University. It was a hard choice, but I decided that I was going to go back to Ankara. And so that was where I started the Middle East Technical University in '73 and finished in '78. It's 5 years, not because I was lazy, but because the school was closed for a year because of boycotts. This was the pretty turbulent time in Turkey. So it took us 5 years to actually finish the school. So this is the dorms behind me in Me2 in Ankara. This is our drafting class. I don't know how many of you remember. We used to take drafting. You can see the T-square rulers in people's hands. And I don't know why we took that class. Never used it, never did anything with it. But this picture was taken in front of our building. By the time I think we were sophomores, there was these talks going around, people saying that, well, you know, that there are a bunch of new professors arrived from the US, young cadre of professors, and we're going to be starting to take some classes with them. One of them was from the University of Wisconsin, worked with Warren Stewart and Lightfoot's Stewart. I said, wow, That's great. That sounds good. Another professor was from UC Davis, worked with Joe Smith. I said, wow, that sounds great. And I mean, those were excellent and outstanding professors. I mean, I really owe them a lot in terms of our education. And of course, I should acknowledge them as well. I did also some extracurricular activities here. Not so much acting, but I ended up doing some folk dancing. This is from the Artvin region, northeast. This is the Sivas region, which is actually down here. So, as MeToo was coming to an end, the decision was, should I go for a master's? After thinking about it a little bit, I decided to go back to Istanbul, and Istanbul to Boğaziçi University. And I worked with Professor Ali Çınar and basically put together a thesis on modeling and simulation of autothermal reactors, which essentially it was an ammonia synthesis reactor. But at that time, the dynamics or simulation of dynamics was a big deal, and we were using Fortran code and punch cards and all that stuff. This is old stuff. It was a lot of fun, and during that time, I started dating one of the senior undergrads, and we ended up getting engaged and getting married. We got married August 1st, and then August 24th of 1980, we were on our way to the US. I got accepted in RPI, and we packed our bags, moved upstate New York. For those of you who may not know where RPI is, this is New York State. Here's Albany, the state capital. Here's Troy, about 15, 20 miles from the state capital. Does that remind you of any other place? It was good times. We had a nice transition because we had lots of good friends. Some of them old friends, and we made some good friends. So this was the Turkish contingent, and my PhD mentor, Yaman Arkun, here with the beard. And this is actually Mine's baby shower, because she was expecting our first child. For those of you who are from Koç University, they may recognize Professor Murat Tekalp, electrical engineering and dean, former dean. And Varol Akman is a professor at Bilkent University back in Turkey also. The winters in Troy were harsh. You can see here, I don't know if you can see, this is my car. I had a 1972 Chevy Impala, and it's a big car. And it's buried under that, and I was trying to extricate it, as you can tell from that picture. So our daughter was born, and that's my parents right in front of our apartment in the student housing there. So during that time, while I was going to school, of course, one of the names that is well known at RPI is Professor Henk van Ness of Smith, Van Ness, and Abbott, the chemical thermodynamics book author. He wasn't teaching the graduate course at the time. Mike Abbott was, so I took the course from Mike Abbott. But I was a TA of Van Ness. So that was very nice, because I think a few years after that he retired completely. He wasn't really doing any research at that time. In 1992, I attended my first conference, American Control Conference in 1982 in Washington, D.C. Actually, it was in Arlington, Virginia. And this was the research group that Yaman had at the time. 3 PhD students, Peter Putz, myself, and Vasily Monosyudakis. And Niall is looking. Is that him? Yeah. And Ram was the master's student. Peter went on to become an engineer at the European Space Agency. And Vasily Manouchiakis, of course, is a professor at UCLA, for those of you who may know him. Of course, a couple of observations here. I don't know if you noticed it. His tie, or the length of his tie, and length of his tie. There's some congruency there. And also, I don't know if you noticed that this is my wedding suit. We was poor. So, coming to the research, of course, we were doing research at RPI, among other things, of course. And the key keyword those days was robustness. And I sort of gave a definition of it here, but from a process control standpoint, the key criteria are to make sure that the system is stable and it performs up to specifications. But these things may not actually be obeyed if the model that you used to design your controller is not quite the same as the actual plant. So if there's a difference between your model, a mismatch between your model and the plant, the controller may not be robust. So how do we design robust controllers? So Vasily and I basically put together this paper while Yaman was gone for 4 months for his military duty. And it was basically about decoupling control, because in decoupling control for distillation, you use explicitly the transfer function model that you drive for the column. But if the column is especially high purity, that linear simple model doesn't really represent that system as well. Therefore, you have issues. So we used some criteria to be able to tell when and how we can assess the robustness. And Vasily actually proposed that we should use the word evrostia, suppose it's here, right? Which means robustness, apparently, in Greek. And we used epsilon to denote that the criteria that we used to distinguish this. Now, as far as my PhD goes, though, this wasn't quite my thesis. My thesis sort of derived from the earlier work that Yaman did with George Stephanopoulos, and that's him here, sort of a family portrait. And the way that George was approaching the problem at the time, along with Yaman and Manfred Morari, was a more of a holistic approach to the design problem. Not just the design or synthesis of the plant, but also looking at all its aspects, including control. So how does one reconcile all those objectives? So my job was to look at the chemical plants, design them, not only design them in terms of the steady state economic constraints and objectives, but also make sure that they can be controlled well and they show good operability characteristics. So that was essentially the heart of my thesis at the time. And so keep that in mind, because after that, that theme does not quite appear in my research portfolio. I sort of left it at that point, and you'll see why in a few minutes. So, and then I started in Davis, 1984, as Roland said, and our son was born about 3 weeks after we arrived. There he is here in one of our holiday parties. The person in the background is Dr. Alberto Goanaga, who holds the record of the shortest successful qualifying exam with 15 minutes, which I was a part of the committee. And after 15 minutes, it was obvious the guy knew everything. I mean, there was no point in wasting everybody's time. So the first couple of things that I did when I arrived, I continued the idea of the robustness, the model uncertainty, and how it sort of related to control. But I started working on a slightly different problem. I started looking at tubular reactors. In this case, tubular reactors are not represented by ordinary differential equations, but partial differential equations. And that complicates things because you need to simplify them. If you simplify them and turn them into ordinary differential equations, you lose some information. Even after you turn them into ordinary differential equations, you also have to reduce the order of that model because it becomes a pretty high order model. And Scott Owens, an undergrad at the time at Davis, helped me actually put together this work. And so we were looking at the influence of the decisions that we make. I mean, how do we discretize? How do we reduce the order? And what are the implications of those on the control? During that time, also, Dr. Wayne Beckett was here for a year teaching after his PhD at the University of Texas with Tom Edgar. And he was sort of looking for a job. And so he came here to basically think about his future. And Karen and I and him put together this work, which again looked at the model uncertainty descriptions for high purity distillation control. And Wayne ended up moving on to RPI as an assistant professor after his stint at Davis. Then he became chair over there, and he's still over there. Scott Owens ended up owning a company, and he's currently a member of our advisory board. So, interesting karma here. Glory days. So we were also doing some soccer playing at the time in 1986, and some interesting characters. I don't know if you people remember Mike Meyer. He was the manager of the center facilities downstairs. I'm here. Alberto Goanaga, professor. And David Cipolla, he was working with Dewey, Ryu at the time, masters, and he's now a VP. And a bunch of our undergrads, he's Rich, Ed, and Jimmy, and Linda. So it was a good group. And I don't know if you noticed, our team name was Burst Stewart Lightfoot. What do you do? So that year, 1989 to 90, there were two people who also came to Davis. I mean, you can see what's going on here. I mean, Wayne was here, and then Jose came, and then David came. So it was a very sort of active years, the first few years for me, which was actually quite lucky for me. David Platt came from Israel, from Rafael at that time. He stayed for a year. And Jose Romagnoli, he was on sabbatical at Minnesota, and then decided to take another year of sabbatical, and then came here. That's the first time I met him. I never met him before. He knew Steve Whittaker. So Steve Whittaker essentially organized his sabbatical, and then we ended up working together, of course. Tom Ramsey was from BioAg. He retired now. So he and I and David put together a couple of papers on cross-flow drying, and we basically developed the models and then developed some controllers for them. And the first papers that that Jose and I put together, in which Karen is also a co-author, was done by Keith Frusetti, the PhD student at that time. And it was about cautious control, which basically meant that in the model predictive control, you're trying to sort of estimate what the next control action is going to be. That's what the predictive part of that controller is. And in the cautious version of it, we were trying to see what kind of uncertainty there is in the model, and then try to move cautiously in the next step. So that was the gist of that work. Keith is currently a senior executive at EPRI, Energy Power Research Institute in the Bay Area. And then in 1989, I was playing soldier. I went to Burdur for 2 months for the compulsory military training, which basically consisted of marching a lot in the heat. And I ended up, I think, shooting 3 rounds using a rifle that I think was leftover surplus from World War I. So that was the gist of the training. And one of my friends sent me this card afterwards. Glad that I made it through. So this is again in the 1989-90 time frame. So by that time, Jose and I clicked quite a bit. So I ended up visiting him actually 3 times during that time in those 8 years. And by the time that I visited him last, he actually moved to Australia, and then after several years, he moved to LSU, where he is now. But so this is actually a piece from the local paper. In town of Bahia Blanca, where the University of the South is, the university or academics information goes into that paper, and my seminar was actually announced in that paper. I don't think Davis Enterprise does those kinds of things. So I was in the paper. I don't know if you can read it. It says El Doctor Ahmet Palazoglu del. You can see the rest. And I worked with several people in that group, in Jose's group, including Osvaldo, Jose Luis, and Professor Alfredo de Sajes, and Hector Cicciarini. I mean, these were terrific people. Maria Colantonio. Again, the theme is about robust control design. Now we are sort of modifying the uncertainty descriptions to include more structure. What that means is not just how big the uncertainty is in terms of its magnitude, but also its phase behavior or its directionality. So that's what that structured uncertainty meant at that time. So during that time also, one of our Bill Ford, who was a I guess he was a R&D engineer at Harris Semiconductor. He contacted us and told us that he had a brilliant idea. He wanted to grow gallium arsenide crystals, single crystals, for semiconductor applications, of course. And gallium arsenide, of course, at that time especially, was a big competitor for silicon. And these crystals were grown through a couple of different, Czochralski, I guess, was one of them, and then the Bridgman technique. And then his idea was to not to use the sort of the cylindrical growth furnaces, but create a horizontal furnace, which he thought would somehow minimize the thermal gradients, therefore minimize the dislocations that result from thermal gradients. We started a lab downstairs in Boehner in the basement, and things didn't work out. So that was kind of a bust, I think. We had ended up with lots of stuff, leftover gallium arsenide all over the place, but other than that, not a big success. But at the time, Greg Young was around, and he actually got a couple of papers out of it, but essentially computational work. So he looked at the same problem, but instead of doing experiments, he ended up putting together a very nice couple of papers on free boundary convection diffusion problems. He went on to become a professor at San Jose State, and he retired actually a few years ago. He was chair over there, that's right. Moving on, so now we're into the 1997 time frame, but the end year here is 2017. Actually, I should have just said present, because the work kind of continues, as I will tell you in a few minutes. Now, moving away from the robustness kind of ideas or the model uncertainty, we started looking at nonlinear systems directly. And then the characters here are Ken Harris, Omar Galan, and Sandra Norky. These two were Jose's students when he was actually in Australia, University of Sydney. And they came to Davis to carry out experiments in this rig. This was our pH control experiment. That rig ended up, I think, giving us 3 or 4 papers. A couple of them are over here. And what we were trying to do in some of these was looking at the nonlinearity in the pH system, which is basically due to the titration curve. This static nonlinearity due to the fact that the pH changes differently as you add the reagent. So what we did was, or Omar in this case did, was sort of divided this titration curve into 5 linear models. So we approximated the nonlinear system with 5 linear models, hence the name multilinear system, and then designed controllers for each of these linear regions. And then what happens is that as you sort of go up and down in the pH, you use the appropriate controller. You switch to the controller and then use that controller, and that obviously does much better, which is the solid line here, than the typical PI controller, which tries to control it over the whole region. Ken Harris's work was very nice, and he focused on what we called at that time functional expansions, which allowed us to define what we called nonlinear transfer functions. So the transfer functions are typically linear transfer functions for those of you who taken control. But he was trying to define nonlinear transfer functions, and that work actually was continued by Zai Qi, who was a visiting student from China a couple of years ago, and he's still actually continuing that work. So Ken's legacy continues in a way. And Ken's thesis at the time was awarded the inaugural, I suppose, the first time, Zuhair Munir Dissertation Award. So he was the first winner of that series. Bit of a different flavor. While I was doing nonlinear control, I also was doing something else. I don't know if you know Alice Walker. She was the author of The Color Purple, which was made into a movie and all that stuff. She wrote lots of books, among them for poetry books. And a friend of mine who was finishing his anthropology PhD in Stanford, whom I know from high school, he and I basically were very interested in her poetry and decided that we should translate her poetry into Turkish. We did. The book was published under Ahmet Nazım. I wasn't using my last name, so it's a bit more classy that way, I guess. Pen name sort of thing. And then I met Alice Walker and then interviewed her. And the interview got published in Milliyet, one of the dailies, Turkish dailies, at that time. I guess this was, 1988 May. So a bit of a diversion from the other kind of stuff. I never included this in my publications. Perhaps I should have. Now, back to the research. If you remember, Scott Owens' work was on tubular reactors, and we were trying to look at the robustness of the design decisions, the control design decisions. I kind of came back to that idea of looking at distributed parameter systems, which are essentially systems described by partial differential equations. So that was the work that Eric did. So here's Eric Henzik and I having some fun. And the person in the background, I don't know if you recognize him, Niall does, Frank Doyle, currently the dean at Harvard. He and Eric happened to be roommates back in Caltech days, so they knew each other well. And Satyam was the other PhD student who did the later work. So the first work that Eric did was, again, looking at the work that similar to what Scott Owens did, but instead of doing it a bit sort of an ad hoc fashion, he wanted to define the region or the space within which the uncertainty lied. And he defined it as using these what he called eigenvalue inclusion regions. And that allowed him to approximate the model or actually characterize the model approximations and then use it to design controllers. I give credit to Professor Karakash and also to Satyam for figuring this out, because this was a very tough problem using symmetry groups and in invariance conditions to design nonlinear distributed control problems, and which included no approximations. So this was, in a way, a bit of a breakthrough, because in that sense, and still people approximate distributed parameter systems with finite dimensional systems to come up with the controllers. This basically avoided that whole thing and developed a nonlinear control system rigorously from the model itself. So by 1998, and this is a thread that also goes until today, we started another sort of a line of research, which was trying to understand how we can detect abnormal situations in chemical plants. So abnormal situation management is about how quickly we can detect an abnormality and how quickly we can diagnose it, find the root cause. The first work started with James Wong. Wei was involved, Wei-san was involved, Fuat Doymaz was the other PhD student, and then Shri Gajar was the basically the last PhD student who worked on these problems. And then a few visiting students who contributed to this, along with a master's student, Chris. The first work, again, collaboration with Karen here, looked at how we can actually look at a time series, the numbers, numerics, convert them to symbols, and then use those symbols through what we call the hidden Markov model to classify what those trends look like. Sort of going from the symbolic trends, and then be able to say what kind of trends what kind of classes those trends belong to, normal class or abnormal class, and so forth. So that was the idea there. More recently, we have been looking at principal component analysis, and you actually looking at sparse principal component analysis. In a nutshell, principal component analysis takes a matrix of data and then transforms the variable dimensions into another, space in which the dimensions are now orthogonal to one another. It's a linear transformation, and then each variable, of course, has their own projection on the new directions, which is represented in this box here. So if you plot the in 3 dimensions, the 3 principal components, and how each variable projects onto those, which are called loadings, it looks like a pretty busy plot. This is also some sort of projection of that. But if you do sparse principal components, basically saying that the variables that contribute very little to that direction may be suppressed and gotten rid of, then the picture looks much clearer, as you can see in these plots. The consequence of this is that now I have a much better idea of which variables are actually correlated with one another in a structured way. That allows us to do process knowledge discovery and also fault detection and diagnosis, because the signatures are now much cleaner, because I don't have the sort of the confusing or the confounding effect of all the variables, but only the ones that are important that contribute to that direction. Back, sort of stepping back a bit, in 2002 and 2003, I took a sabbatical. First 3 months was with Professor Frank Algover in the University of Stuttgart, and then the 6 months with my PhD mentor Yaman Arkun and Burak Erman. This was the winter time in Koç. They have a beautiful campus, as some of you know. This started in sort of a new area for me. And because of that, I guess it was a very productive sabbatical. We started looking at how proteins fold. So this is the sort of initial configuration of a protein, and then it's supposed to fold into this native configuration. And Burak Erman was doing simulations, molecular dynamic simulations of this. And then we said, maybe I can look at this as data and trying to find out if we can sort of identify certain landmarks and interactions among different residues that tell us something about the folding event, and how the protein sort of goes through these events, which sort of secondary structures fold first and fold next, and so on and so forth. That, after I came back here, I was happy to find out that Roland Fowler joined the department, and he was doing very similar things. So we started a collaboration, which I think is sort of, I'm showing just this paper, but it also includes a margin here somewhere. Again, we were looking, in this case, we were looking at some peptides and how they were folding. These are short protein chains. And we were able to sort of see which modes are active. And these are sort of the stretching modes, or the sort of horizontal stretching, this kind of stretching, or others, and how they sort of project themselves in time and contribute to the folding process. So it was a very interesting work at that time. And as Roland mentioned, I said continuing a tradition. I feel humbled saying that, because this department does have a tradition in writing textbooks. Of course, Joe Smith's couple of books, Professor Whitaker's, Jim Shackelford's. So I'm happy to contribute to that, at least this much. So this was a sort of a culmination of our collaboration with Jose Romagnoli. And so we are in the second edition right now, and I'm not sure if we're going to go to third. And then there was this other book, which was sort of co-authored with my master's mentor, and which was about all the fault detection, diagnosis, monitoring kinds of work that we were doing at that time, and sort of putting it all together. It was more of a research monograph. Another interesting line of research at the time, again, using the idea of the principal components and using big data as the starting point, was how does one look at wind measurements, start with the wind measurements, surface winds, classify them in such a way that you come up with key weather patterns, and then see how these weather patterns are related to air quality events. In this first paper that we published with Scott Beaver here, the work was essentially about ozone exceedances in the Bay Area. We were looking at summer, because that's when the ozone is a problem in the Bay Area. And we were able to identify 4 clusters, or 4 regimes, 2 of which led to significant ozone behavior, and the other 2 didn't. And we were able to explain why, and sort of made the connections. This was, of course, the first paper that I published in this journal. Believe it or not, there were 3 reviewers, 5 to 6 pages each, and they were positive. So we got it published. I mean, I don't think I've ever had a review after that like that. That was amazing. So in this paper, we are looking at particulate matter, fine particulate matter, PM 2.5. And in this case, we're looking at winter months in the Bay Area. And here's how the weather patterns look like. These are cluster average synoptic patterns, which means you're looking at the pressure patterns, I guess, about 18,000 feet. So you have a ridge pattern off the shore. This is our Bay Area here. And this is more sort of onshore ridge, and then this is a kind of a weak ridge on inland. These were essentially the high pressure patterns that led to most of the fine particulate matter events. This is a ventilated, I guess, pattern. As you can see, the winds are sort of westerly, and this is the storm during which all the rain occurred. So we were able to classify these things nicely. You can see the wind patterns, the surface wind patterns. So this is basically easterly, and then you have the easterly winds for the R2, and then very sort of stagnant winds over here. Here's the storm pattern, and then here's the sort of the delta breeze kind of a pattern, as you can see from the bay. And we were able to show that the R2, which is this, was the sort of the responsible pattern for these events. I have to mention HUMG because it is one of the fun things that we do. Bob started this back in 2011, and many of us participating in this teaching. It is a challenge because we are expected to teach in 2 weeks, essentially one of our courses, quarterly courses. And actually, Niall is leaving tomorrow to go there, and Roland and I are leaving next week to go there, along with Professor Higgins, who's over here. But it's a lot of fun, but it is a challenge. But we enjoy and doing that. I think Tanya is down here. So, what's happening today? So this is more recent work, and with the Niall, we started this back in 2012, along with Shannon Wang, who's now an assistant professor at the National University of Singapore. We started looking at the design of processes with demand-responsive features. And I say here, back to the future. Hopefully you'll see what I mean by that in a minute. So the point is, the electricity prices change during the day. And it's a free market in most cases. Either it's a set price during the day, or it could be actually time of use kind of a pricing, or it could be essentially freely changing market as well. And if you are also, if your system or plant is connected to any kind of a renewable source, you have renewable energy, in this case wind, which is shown in green, certain parts of the day, and especially if it's solar, you only have solar during the day, and especially if it's not cloudy. Given this, how does one operate a chemical plant with this background? Or if you ask the question another way, as a residential customer, we tend to sort of shift our loads, meaning if the electricity is expensive, we don't do our laundry at that time, or essentially run our dishwasher. We try to do that during the cheaper times. And the idea is, can a chemical plant do that? Or can we design a chemical plant that can do that? And Shannon's work, original work, was focused on the network of heat exchangers, which can be operated during the day with, in this case, I'm showing two different configurations, which basically are different where this heater actually goes. So this heat exchanger network will be active during the peak hours. This will be active during the off-peak hours as far as the electricity price goes. And based on that, she was able to show that you get excellent savings if you were to only operate the network with a single configuration. So if you switch between the two configurations, you get lots of good savings. So that's the current focus of our work, and how to sort of design these chemical plants, trying to understand their behavior during the day and optimize their behavior during the day to take advantage of these changing electricity prices and changing solar and wind or any kind of renewable energy supply. I said back to the future because it kind of goes back to my PhD thesis. Because what I was doing there was sort of looking at the design and trying to combine it with dynamic operability criteria. Here, we're still looking at the design, but in this case, operability is coming from the side of from the demand response. Different objective, but very similar kinds of concepts. So in that sense, I guess it's back to the future. Speaking of future, what's next? I'm going to start with this. This is actually kind of current work, but it's because it's ongoing work. I'm going to call it a bit of a future. This is carried out by master student Kuang Sheng and Xuan Kai, who is a visiting PhD student. We're using deep learning methods, methods like word embedding or things like recurrent neural networks, natural language processing, NLP, and so forth, to understand how we can predict alarms in a chemical plant. When these alarms happen, of course, the operators need to respond to them, and if a lot of them happen, they are confused. So they need support, and the question is, can we provide them with that kind of support? We're working together with the UC Davis utilities. They actually have a very nice SCADA system which collects data continuously from their central cooling and heating plant, as well as water treatment plant and many others. So this is from the central cooling and heating plant for the whole year, and just showing what kind of alarms are happening during that year. Apparently this was, I guess this is November and December. We're working together with David Trombley. I don't know if you remember him. 2006 graduate of UC Davis. He went to University of Texas, got his PhD, and then came back, and actually he's now an engineer at the facilities here. So I'm working with him to do that work. Roland mentioned this. So starting in August, I will be in Denmark, spending time with my colleague Murat Külahçı. I was awarded this Otto Monstedt visiting professorship there, so I'll be doing some research basically on fault detection diagnosis using various techniques to attack that problem, which we started with Murat a few years back. So that's essentially the near future, and I think we're right on time, or kind of a couple of minutes late. I'm going to leave you with this poem. I'm going to read sort of the last half. And though we are not now that strength which in old days moved earth and heaven, that which we are, one equal temper of heroic hearts, made weak by time and fate, but strong in will, to strive, to seek, to find, and not to yield. Thank you very much.